getting ready and here on the call. Okay, we're going to go ahead and start the webinar, and thank everyone for joining today. This is Jeff Mucci with RCR Wireless News. I'm Editorial Director of RCR, and today's topic is sponsored by Tellabs. The topic is small cell backhaul, what, when, and how. We have two speakers today, Stu Benington, who's Director of Portfolio Strategy for Tellabs, and Tuuli Sarvilinna, who is Group Manager for Product Marketing. Before we get started and before I turn over the presentation to Tellabs, we're going to take a short poll just to gauge the audience and your interest. And what I'll do is I'm going to leave this poll open for about 45 seconds or so. And what I'd love to do is if folks could just give us, select one of the options there and give us a sense of which of these areas are most interesting to you. Looks like we've really got good participation as it stands right now. About 60% to 65% of the attendees are voting on the financial model. So we appreciate the participation. I'm going to hold the results of this until the end of the presentation, and at the end of the presentation we're going to leave plenty of time for Q&A. But I do encourage attendees on the webinar to submit their questions. The speakers will be monitoring questions and will do their best to answer questions during the presentation as they come in as appropriate. But we will have 10 to 15 minutes at the end of the webinar for general Q&A. Okay, so I'm going to leave it open for another 5 seconds, and please make your final votes. By the way, we've got close to 200 people attending the webinar today, which is good attendance. Thank you very much, and I appreciate your participation in the poll. I'm going to close it, and Stuart, I am going to turn the presentation over to you right now.
Okay.
Actually, John, would you mind going ahead and making that change for me, please?
Okay. Thank you. And I guess, Jeff and John, I'll just get started then.
Yep.
Okay. So thank you all for joining today. The topic of the presentation is small cell backhaul, what, why, and how. And I'm joined today, by the way, my name is Stuart Benington, Director of Portfolio Marketing for Tellabs. I'm joined today by Tuuli Sarvilinna, who's our Group Product Manager in our Mobile Routing Group. And so we're going to be covering this presentation in two pieces today. And if we go to the outline, what I'm going to start off with is a market review. And we find it's always important to take the perspective of what the operators are trying to what the operators are trying to solve in the network, and what are the problem statements associated with the challenges that bring small cells into the equation. So what's happening in the network, what are their objectives as they move forward with later generations of deployment, and then what are the market opportunities and use cases. And then after laying that foundation, I'll turn it over to Tuuli, and she's going to focus specifically on the backhaul component for small cells. And what we'll find is that there are some challenges and solutions that are similar to traditional macro cell backhaul, but there are some differences. And there's differences in the topologies, there's differences in the economics and the operational environment. And then she'll close with what the focus areas of methods for building the most efficient backhaul infrastructure for small cells. And then we can, at that point, take some questions and focus on zeroing in on any of these specific areas that we think are most interesting. So with that, I'll start with the market review. And really, what we start with is, fundamental challenge as operators migrate their mobile networks is first and foremost how to address this increasing data traffic in mobile networks. We all, I think, know that there's a continual sort of a wave of increasing data traffic. A lot of it's driven by video. There's machine-to-machine traffic. There's hosting of services from enterprises in the cloud and so forth. So there's a confluence of events that are placing increasing burdens on the mobile network and thus driving things for mobile operators to accommodate that traffic in a way that makes the most business sense and provides the most lucrative business models. So how do we do that? First and foremost is spectrum efficiency. With mobility, everything starts with the spectrum. So there's a continual push even now to moving to later generation of 3G modulation and 3G infrastructure with HSPA, HSPA+. There's also, as we know, certain operators that have been very aggressive pushing toward LTE. Others will follow shortly thereafter. And then LTE advanced as sort of the next step beyond that brings into play not just increased capacity, but a lot of new tools and capabilities for operators to efficiently manage different types of traffic in the network. So that's the first thing. The second thing is just acquiring additional spectrum, and independent of what generation of mobile infrastructure you have, additional spectrum is always a good thing, and having that as an addendum to the existing capacity that you have in the network is a very direct way to be able to accommodate new traffic, but it can be expensive, and there's a finite number of licenses and licensees that are available for that spectrum. So it's something that's available, but it's not necessarily a be-all and end-all. And then finally, there's a topology issue that comes into play, which is the increased cell density. And so there's a couple of different ways that this can be addressed. Number one is just simply increasing the number of carriers per site. So you have a given cell site, and you're replicating carriers at those sites. You can do cell splitting, which increases the total number of cells. And then, as the topic of today suggests, there's this introductory concept of small cells, and we'll get into that and what does that mean and what do those look like, because there's a wide variation of those types of cells and how they're deployed. But that's looking like, as we move over the next 2-3 years, something that's going to be an important and valuable way for operators to address this coverage issue and to improve the quality of experience for end users. So the small cell dynamic is an attractive and we believe a fairly easy way forward for operators to address these needs of data-hungry mobile users, and crucially to do it in a way that makes good business sense for the operator. So what changes when you go from a macro cell to a small cell environment? And I'll preface this by saying that small cells are not intended to be a replacement of macro cells. They're more of a complement to macro cells. So if you look at what looks different for small cells versus macro cells, you see, first of all, that macro cells, if you look at the left-hand column, they address a wide area from a square kilometer standpoint, whereas small cells are, as the name suggests, addressing a smaller area, but they're very targeted in nature. So in other words, they can be used to complement traffic hotspots, or as we call them, not spots in some cases, where you have white space areas in between good macro cell coverage. So those are sort of two different scenarios there. Macro cells, the vast majority of those are outdoor deployments, whereas small cells could be deployed outdoor in a higher hardened environment or indoor, and we think that's going to be a fairly significant proportion of the total small cell deployments for buildings, high rises, shopping malls, etc. Macro cells are, by their very nature, associated with high mobility, whereas small cells, again, given the topologies of how they're deployed and the target applications and use cases they're deployed, probably will be more used in nomadic or limited mobility scenarios. So that that has certain benefits of complexity and cost and so forth, and it just maps to where these small cells will be located. Macro cells, absolutely crucial to have as high availability as possible. They're always on, and they need to have accommodation for resiliency. Small cells, the thesis is that it's less critical for a given small cell to have that standard of availability that a macro cell will. Not because that end users can deal with that, but it's because in many cases, if you lose a small cell, you don't have a complete loss of coverage. You may have a throughput. You may scale back the throughput, or you may have a certain area where you wouldn't have as good of a reception as possible until you turn the cell back on. But it wouldn't be as catastrophic as losing a macro cell. So it's more of a distributed model that can accommodate traffic in various means and in various locations, and thus back up each other in the event of a smaller cell failure. In a macro cell, you have multi-band sector carrier deployments. Small cells typically are single band, single sector, single carrier. A lot of that's for cost reasons, and a lot of that's for just coverage needs. And then topology-wise, macro cells have fewer sites with high capacity. Small cells are more sites with lower capacity and more distributed as a result. So this gives some of the primary differentiation between the two. And again, bearing in mind that the vast majority of small cell deployments will be done in situations where they're interspersed with macro cells in a way that's optimal for the end user. So if we move on to the use cases, there's really three major forms of use cases, and we touched on those a little bit, but it's worth delving into these a little bit more because that gives us clues as to what the networks will look like and the topologies will look like, and then by extension what the backhaul requirements will need. So if we look at this this diagram, this really illustrates three major use case scenarios. In the upper left, we see this capacity enhancement for data offload at so-called hotspots. So if you're in downtown New York or London or Hong Kong and you want to accentuate the macro cell deployments in a way that you can provide hotspot data set coverage, that's a really good way to do it. And that is something that we believe is an important, probably an early deployment scenario for a lot of small cells. The second case is the coverage extension case. So if you look to the right-hand side of the diagram, you'll see that as you reach the outer edges of cell boundaries, there are cases where you'll want to have a fill-in, what we call a not spot deployment, to get a more seamless coverage and not have risk of call drops or session terminations as you move from cell site to cell site. So in that sense, that's a really important way for operators to use small cells to improve the end user experience. And then finally, the third case, and this is more true with certain operators than others, is the aesthetics case. So if you look at that lovely picture down in the lower left-hand column, it's not hard to spot where the macro cell is in that picture. There are environments where you don't want to have big cell towers gutting the skyline if you can avoid it. It's not always easy to take that and replace it with small cells, but in certain cases where you have zoning restrictions, or you just really want to minimize the number of those big towers that are sitting out there, there is a case to be made for small cells, more small cells, but let's say less visually invasive than a big macro cell tower in places where you want aesthetic beauty, either rural or in some cases in urban or suburban areas. So that's kind of the third scenario where small cells make a lot of sense. Okay, a couple of quick diagrams on the market growth. These are two different projections. One's from Heavy Reading, one's from Infonetics. That talks about how many small cells are going to be deployed out there over the next several years. And in the case of the Heavy Reading diagram on the left, you'll see that there's some geographic breakdown of where we anticipate the small cells to come into play. And so you'll see at the top of those bars, the Asia Pacific region really seems to represent a nice market segment for these small cells. But that's not to minimize the opportunity in the other regions. And so the question is, how and where and when will that ramp up take place first? It's not going to be, an immediate hockey stick next year, but over the next 3 years, you'll see that the projections are a fairly significant increase in the number of cell sites that are going to be out there for small cells, starting into 2013 and then really accelerating into over the 3-year time horizon. So I'll wrap up my section by talking a little bit about the different needs and solutions associated with small cells. And as we look at this, bear in mind that there's a couple of different variables that are going to come into play for operators in a heterogeneous network deployment, or a HETNet type deployment. So first, you have the case where you have your traditional metro cells and micro cells, which are smaller but deployed in the same, similar configuration. The idea then is to supplement those deployments. That can be done through femtocells, that can be done through picocells, and that can be done through remote radio head ends. And that's a little bit of a different case, which I'll talk about in a minute. So a couple of themes here to bear in mind as we move toward the backhaul portion of the presentation. Number one is there is no universal case for one single type of cell and one single reach or breadth of how big the cell site will be. It'll be a mixture based on demographics, based on user profiles, based on how fluid the traffic is within a given area. And we anticipate that there will be a high combination of these different types of cells based on the business model for a given operator. And no two networks ever look alike. But the nice thing about this evolution from larger cells or macro cells toward the different variants of small cells is that it affords operators with a high degree of flexibility and enables them to really address this very challenging infrastructure build-out problem as they move from the different generations of 3G onto 4G and have to really be judicious and focused on how they engage that deployment of the radios. One point on that last piece there, which is the remote radio heads and the baseband pooling concept. If you're not familiar with that concept, basically what that function does is that it centralizes functions that were traditionally distributed out at the endpoint, at the cell site. So DSP processing, for example, can be centralized in a pooled mechanism, which gives a lot more flexibility for capacity allocation as needs warrant across a wide number of cell sites. So in this sense, it's a flexibility variable on top of the other variables of size of cells and locations of cells, and it's something that can potentially be a really nice way for operators to make their networks more flexible and accommodate different traffic fluctuations and topology variations over time. I'll also mention that isn't, we'll say, radio generation dependent. In other words, you can have a mechanism there that accommodates GSM all the way up through 4G. It's not dependent on any given generation of mobile technology. So if you summarize all of these points into a couple of central themes, the small cells play an important role for operators to manage the business model and manage this increasing demands on the network driven by big data generation, driven by video, and so forth. And it's a combination of three major themes. One is the transition of mobile network generation. So in other words, 2G to 3G to HSPA, HSPA plus, LTE, LTE advanced. Then there's the combination of cell sizes and cell architectures, so metro cell, micro, femto, pico, and remote radio head ends. And that ties into the third piece, which is the baseband pooling, or the flexible accommodation of managing traffic across multiple cells in a way that best suits the traffic patterns at that given point in time, and thus makes the networks as efficient as possible for addressing that traffic while providing the best end user experience as a result. So that summarizes the setup piece, and what I'll do now is I'm going to turn the presentation over to my colleague Tuuli Sarvilinna, and let me pull this up here. All of a sudden I don't see her. Guys, which tab is it to transfer that again? John?
I'll take care of it, Stuart.
Okay. Okay, I didn't see her. Okay, great.
Okay, so while I'm setting up my screen, we are doing this webcast from 2 different locations. So while I'm setting up my screen, let me introduce myself. My name is Tuuli Sarvilinna, and as Stu said, I'm going to talk about the mobile backhaul, in a bit detailed manner, and this is going to be the deep dive to the small cell backhaul now from our side. So thanks a lot, Stu, for doing the opening marks. And now when we talk about the backhaul, let's go through a couple of challenges in the beginning. When operators start to deploy and plan the small cell specific backhaul, they will run into a couple of issues. The first is related to the coverage and capacity, and then the second one is related to the cost. On the coverage and capacity issue, there will be a couple of things that operators need to keep in mind, and Stu was already touching those a bit. The new kind of a location is, of course, going to be, one of the challenges. Macro sites were often located to sort of dedicated locations, either on the rooftop of a building or top of a hill and so on. But these small cells, they will really, bring telecommunications to the street level. We will see small cells on lampposts, on bus stops, on walls of the buildings, and locations like these. And these new locations will obviously require a completely new type of planning, and they will be affected by new kinds of environmental issues and requirements as well. As we can all, think through, and Stu also mentioned this briefly, the design of the small cell devices is going to be a critical thing for all of the operators. Macro site can look whatever it does, and there won't be too many complaints from the mobile users, but if you are locating small cells into a high streets of London or Paris or Chicago or LA, city councils will definitely have their word on what's going to be the look and feel of the device. We are also assuming that many of the operators are going to meet a challenge where the regulations of the cities won't allow operators to have multiple different small cell options in a single lamppost, and this might drive operators to do something called shared backhaul or shared small cells. So there might be a single enclosure that needs to contain then all the possible operators who want to go to a certain location. And just like with macro sites, I mean, small cells will have optimal locations within the street level, and these locations will be then something where most likely sharing will happen. And of course, street level we'll have other challenges as well. A colleague of mine was telling about small cell trial where everybody was wondering what happened in the 1st of December because the quality of small cells was dropping badly. And the reason for this technical issue turned out to be the Christmas decoration of a certain city. So, there will be new issues that we all need to be able to deal with when we talk about the small cells and the backhaul. Outside of the location-based things, of course, there will be challenges with power availability. Lampposts obviously have some sort of a powering options, but is that sufficient, and is it going to be enough for small cell powering, which will often include just the radio side of the small cell, but also some sort of backhaul radios and sometimes aggregation devices as well. Of course, regular powering options are available in operators' toolkits, but then there might be considerations for power over Ethernet or some sort of intelligence or new emerging powering options that might help with the overall situation on doing the deployments. One of the key things is, of course, going to be the backhaul availability. Very few lampposts are equipped with fiber. That would, of course, be a nice case if that would happen, but that's seldomly the case, so operators need to find new ways to reach the small cell locations. And I'm going to touch that topic a bit later. And then, of course, security requirements will also be an issue. These locations are, in outdoor locations often. Locations are normally easily reachable, and then different sort of attacks, either virtual attacks or telco attacks or just physical attacks, might threaten the small cells. So operators really have to plan, the security requirements and meet tight security requirements and take that into account in their planning as well. Then let's talk about the cost side a bit, because that's gonna change as well. Macro sites, there are of course many of those, but not as many in a dense, limited area as they will be in small cells, as they will be small cells. So small cell deployments, whether we follow the heavy reading graphs or the phonetic graphs or some even more sort of like radical looking graphs from the industry, we can see that the volume of the small cells is going to be high, and operators will need to roll out in a fast and rapid way hundreds and thousands of small cells into dense urban locations. Of course, this will require lower cost devices than what we have seen at the macro sites. So completely new type of set of devices, also from cost point of view, will be needed to address the small cell deployments. Operational expenditures will be another critical thing. There will be large-scale installations, and if the installation cost is high, and if the maintenance cost of a small cell is high, it might actually ruin the entire business case for these small cells. We have to recall that small cells are often just built for the data availability or for the data services, and there ain't that much revenue available on data services, but then there will be massive requirements for these installations and maintenances or maintenance, and that needs to be addressed in a clever way. And one of the ways to lower the overall cost related to small cells is then to look at the leasing case of mobile backhaul. Sometimes it might be cheaper to lease the connectivity from a wholesale operator than do the build out on operators or on your own. And sometimes it's also viable to look at sharing options. As I mentioned, sometimes the locations must be shared by the regulation, and sometimes it makes economically sense for the operators to look for the sharing alternatives in order to lower the total cost of ownership on small cells. But definitely, small cells are a different game than what the macro cells used to be. So new game plan is needed for the backhaul as well. Then let's take a look at the closer look at the small cell architectures and how the deployments are going to be made. It will be definitely an interesting topic for the operators to find out the best locations for small cells. I think those are going to be driven a lot by the coverage. Where can one get the best coverage for highest traffic loads? Where are the high streets of certain cities or most popular theme parks? Or then at the cell edges, where we talk about these not spots, operators must also consider that what's the best location for a small cell to cover the widest possible area, because most likely there won't be that much traffic, but the small cell is rather used to bring in traffic for the cell edges, especially where the coverage of a macro site may not be enough. And then of course these locations will be or need to be carefully selected. When the locations of small cells are selected from either coverage or wide area coverage or traffic coverage point of view, then operators must also take a look at the actual topology of the network. When these locations are identified, it makes sense to look whether they can be combined to each other in a certain way. And then we go back to the classical telco topologies, point-to-point topologies, where the small cell locations would be directly attached to either a macro cell that would work as an aggregation location, or maybe to another aggregation location where fiber connectivity or some sort of a fixed line connectivity towards the controllers and gateways of the network would be available. Of course, there will be chains as well. I think especially when operators are covering certain streets, street, this might make sense to chain small cells, and then from a particular point where you have either line of sight radio or you know, some sort of other connectivity to the macro site or aggregation locations, then end the chain to a higher capacity macro aggregation location. Some of the small cells might be built in mesh as well. That can offer also redundancy options, some sort of redundancy for areas where that might be needed. And then of course ring topologies can be considered as well. So I think we will see a completely new sort of aggregation layer as well within the small cells, and completely new sort of set of topologies between the small cells and macro or aggregation sites as well. And then operators need to do careful planning on what's the best way of tying these topologies into the existing backhaul network. And of course, availability of the existing backhaul within small cell chains will be one of the dominant criteria for these topologies. And of course, the availability of new builds. So where can one build efficiently some sort of a backhaul capacity will be then criteria for the topologies and small cell locations to a certain extent as well. And then power availability and maybe the possibility to do power over backhaul are then considerations that operators must take into account as well. Okay, let's move on and then take a closer look to the greenish lines that I have here between the small cells. What sort of backhaul link options do operators consider and can consider for the connectivity between the small cells or between the small cells and aggregation locations? Fiber backhaul is of course one of the options, and I think it's kind of maybe the most popular one if it's just available. It offers of course low latency, long distance connectivity, and a great capacity range. So those are clear benefits of the fiber installations. Unfortunately, it's seldomly available at small cell sites. So as we discussed, a lamppost doesn't necessarily have a fiber connectivity into it, and then you have to look into other options. Simply because fiber is normally extremely expensive to deploy and often also expensive to lease, especially if you're doing that on your own. DSL or copper is the next option that operators often look at. That's of course a fixed technology again. There you need to balance between the distance and capacity that you can gain with different DSL technologies, and of course also the topics of quality of service. How do you bring quality of service differentiation into the DSL lines? Is the quality you get, for example, from the leased DSL connectivity enough if you want to offer, for example, premium data services? And then how are you going to deal with synchronization? So those are all issues that operators need to take a careful look at if they are going to go with the copper deployment. In dense urban areas, however, copper might be available, and it might even reside close to small cells. So that's the clear benefit of the technology. If it doesn't exist, then it's fairly expensive to deploy. Leasing might be more affordable and make the business case for DSL or copper more tempting for the operators. Then if fixed connectivity is not available, then operators obviously must take a look at the wireless technologies. And sometimes it might be easier to do deployments with wireless technologies from the scratch. In wireless technologies, or among wireless technologies, I have now divided the different technologies into line of sight and non-line of sight categories. In line of sight category, of course, one of the benefits is the high performance / distance, especially compared to non-line of sight. But then careful planning is required to be able to deploy line of sight radios. And then one needs to also consider spectrum utilizations and availabilities if that's the direction that operators are going to take. It's going to be easier to build wireless connectivity towards small cells than what it is if fixed line is considered, and of course the deployments are going to be faster as well compared to the fixed line access that one could build to the small cell locations as well. On wireless technologies, I mentioned already that then we have these non-line of sight technologies available as well. They offer lower performance / distance than what the line of sight offers. So that's a drawback on these technologies. But then on the positive side, you don't need the line of sight. So that helps with the planning and and sometimes sometimes non-line of sight radios are the only option available to certain locations where fixed connectivity cannot be built, or it's not available, and where line of sight radios are not available either. I would say that this technology is most likely very good for the last mile, the very last mile, where you only reach a single base station or single small cell. And of course, some drawbacks, there might be a limited availability of radio bands that are used for non-line of sight radios, and sometimes also there might be, cost related to it. Of course, then there's the option of going with non-licensed bands, but then, then another threat opens then on that side, that what is the availability of those non-licensed frequencies, and then also how can they be utilized in a way that the sufficient capacity is available. And then, of course, we have some radio access technologies that some operators are also considering. So I'm not going to touch this in a too detailed manner, but sometimes also options like LTE, TDD can be doable for the backhaul options. So lots of alternatives, but all of them having their own pros and own cons as well. Then if you look at the some of the other topics on the small cell backhaul, of course the small cells themselves will not be just a single from functionality point, not just a single device, but they will actually integrate quite a bit of functionality. Integration is a hot topic within the industry just now, and it seems that it means a bit different thing for multiple players of the industry. So for some players, integration is about building in multiple different radio technologies and integrating those into the small cells, while to some others it means that you would integrate the small cell radio with some sort of backhauling capability, either with the cell site gateway, or with the combination of cell site gateway and a microwave radio. Or if you really take this forward, then you might integrate all of this functionality into a single device. And integration level, will obviously bring some benefits for the operators. Installation cost will be obviously lower if you have more integrated device, and then operational costs can be also brought down with this integration. And that's one of the tools for the operators also to look for lower cost of the overall small cell backhaul deployment. Now I would like to go to in more depth with the backhaul area. Some of you might be very familiar with the traditional backhaul, which is normally just done in multiple different ways, and the role of backhaul is obviously to bring the connectivity from cell sites to the controllers and gateways of the network. In addition to that, connectivity role, backhaul also does multiple other things. It often hides the complexity of multiple radio network generations, 2G, 3G, and 4G. Those generations can have their own standardization and own requirements, but a single efficient backhaul will hide the complexity of those layers from the operator's point of view. Backhaul also is often media independent. So different backhaul networks support then different underlying media, radio, fiber, DSL, Ethernet, SDH, and so on. And then it's often utilized or used to optimize the use of radio access network resources, and then also backhaul links and link resources. And then on top of these things, backhaul in traditional mobile networks is often also used to bring a clear demarcation point between the radio and the backhaul domain. And with this defined demarcation points, I mean the barrier between the radio access side and normally an organization that handles that side of the business, and then the backhaul organization that normally builds and is in charge of operating the backhaul network. So between the demarcation point at the controller side and at the cell side, there's normally a defined responsibility handoff between two organizations within the operator, or between the backhaul domain that might be leased from a third party as well. It's crucial that these endpoints offer easy configurations and end-to-end visibility for whoever runs the backhaul network, and also tools and capabilities to do monitoring on SLAs, service level agreements, and testing and troubleshooting capabilities. So on top of the normal connectivity role of mobile backhaul, then mobile backhaul carries multiple additional functionalities that will help operators to to drive their networks and make their everyday life much easier. Now, when small cells are deployed, the operators will basically face a situation where similar functionalities should be actually extended to cover the small cells as well. And I'm going to go through a couple of examples where we can see how the small cell backhaul can be built in an efficient way, utilizing the tools of the current existing macro-based mobile backhaul. So the first point is about doing aggregation at the macro side or aggregation locations, and then do point-to-point connectivity from these locations towards the small cells. So in some small cell rollouts, especially in the beginning of the cell rollouts, operators might consider very small and simple networks which might rely on point-to-point topologies. And in this type of architecture, the point-to-point connections are often directed to an existing site of aggregation where the fiber connectivity or some sort of fixed connectivity is available. And in this picture, I have shown just a macro aggregation site, but it could as well be one of the nodes which is now within the blue cloud. And in those locations, one would do the demarcation handoff towards the cell site, small cell sites. The last mile in here can be very simple, point-to-point connectivity. It can rely on Ethernet connectivity, and then the macro site would work as a demarcation point towards the service. And as you recall, the demarcation point then often helps with the visibility, with the provisioning tasking, with the testing tasks, and with troubleshooting tasks. And for example, in this example, the operator can provision and manage and maintain the connectivity to a certain site, all the way from the gateway sites towards the macro site. And then the last hop to the small cell site is just a very simple connectivity that is done on a point-to-point manner. If we want to take this example a bit further and start to utilize the benefits of aggregation in the network, one can start to optimize more complex topologies with aggregation. And operators should definitely, in those cases, consider demarcation and aggregation devices. And in this slide, I have now a bit more complicated topology where you can see that the demarcation point is now moved away from the macro side to the cell side gateway, and that way operators can extend the domain that they manage from the gateway sites all the way to the cell sites. So this will also then help operators to start to do aggregation at the small cell sites and extend exactly the same tools and capabilities that they have for the current backhaul to these small cell chains. Typically, that means that traffic management, quality of service, synchronization, and manageability will be available also in the small cell chains, and that will of course help the overall operational case in the backhaul. Just to give you an example on why I think this is important, in this example I have now a bit more realistic looking topology described in this slide. The chain on the top of the picture could be, for example, a street, and the ring topology, which I have on the lower part of the picture, could easily be a block of business park area where the connectivity is provided to that sort of architecture. In both of these architecture, multiple small cells are dimensioned to support a peak traffic of 100 megabits. When the backhaul network for these type of topologies is built, operators then must carefully examine what's the most and cost-optimized way of building the capacity for these chains or rings. If you dimension the entire backhaul for the peak traffic, for the 100 megs, you might end up over-investing into the link chains or into the links within the chains and rings, and for each hop, you would then dimension more and more capacity, which leads to higher and higher capacities close to the aggregation points. Instead of over-dimensioning, operators should really consider aggregation and utilize the benefits of it. With quality of service aware aggregation devices that one could deploy within the chains and rings, operators can start to optimize the link utilization. They can start to aggregate multiple partly utilized, let's say, gigabit Ethernet links, for example, or fast Ethernet links into better utilized links, which will obviously lower the capital expenditures and make the operational issues much simpler. And then they can start to add statistical gain into these links as well. So let's assume that a single, cell has a peak rate of 100 megabits. Operators should then consider whether they dimension the entire backhaul based on single peak rates, and that way build a sum of all small cell peaks to the entire end of the chain. Or, could they actually start to utilize more optimized infrastructure with quality of service enabled aggregations, and probably allocate much less traffic for the last mile or for the major hubs that I have here highlighted with the question mark of 400 megabits. So with careful planning, I think operators can really start to gain savings also within the small cell aggregation domain and build optimized architectures and also optimized solutions for manageability and overall cost. But let's talk about manageability a bit more. So before I wrap up, I would like to give you a couple of concrete examples why we think that these operational expenditures are a key thing for operators. Operational expenditures will include not only the deployment phase of the small cell backhaul, but also, of course, the maintenance and operations. Operators will need efficient tools to plan the network, of course. They will need tools to provision the capacity. They will need tools to do efficient deployment of services. And of course, they will need also troubleshoot and testing capabilities within the small cell backhaul, just like they do today within the macro backhaul. A great help in these type of tasks will be an end-to-end management system that will help and take care of the complexities and functionalities in a way that it's easy for users to utilize and kind of optimize the architecture. So if I look at what we have been working with our customers, we've been designing for the macro backhaul lots of tools together with our customers that are specific to mobile backhaul and that can now, for example, extend it easily to small cell backhauls. Operators can use these tools like mass provisioning tools for site installations, plug and play tools for easy installation concept, and then testing tools in later phases of the service life cycle and integrated troubleshooting and OEM tools that all play a significant role in the path towards optimized operational expenditures. Just to highlight what I mean with these optimized processes and tools that we've been building together with operators, let me take an example from the deployment side. In a normal deployment case, the installation and service turn-up is often a task that is done within two organizations. First of all, there is some sort of field team, often kind of doing the actual installation of the devices, and then colleagues from Network Operations Center are normally then doing the actual provisioning of the connectivity in order to do the entire service light up. Normally, these type of processes start with the fact that someone has done the planning of the site, and then a work order for the field operation is placed. And from field operations, then someone goes to a site. In this example, someone would go to a site on 1st of September, and they would then do the installation. Once the installation is done, then the provisioning task would pop up into the work order queue of someone in the network operators center, who would then provision the actual service. If everything goes correctly, it might take just a few days to set up this type of a service. But if things don't go correct on the first place at the site, there might be a second shift needed. And then we kind of like go to a vicious circle where again someone needs to go to a site and again someone needs to do the task from Network Operations Center. And from overall rollout point of view, it might take several days, even weeks, to get a small cell site, for example, up and running in the network. To overcome these type of challenges, we believe that operators should look for self-organizing network features that would automate this type of routine task and help operators to focus on things that really create value for their end user experience, service differentiation, and cost. And these type of automated services would eliminate the process between multiple organizations, and that would streamline really the workload between the organizations in a way that when an installation guy goes to a site, they would initiate an automated, self-organized network equipped deployment process that would automatically take care of all of the site configurations, and then would also notify the installation guy that, hey, everything was done, and all of this could be done within minutes. That would not only lower the cost of operations and the cost of people who are involved into these management tasks, but also would help speed up the network rollout, which most likely will be a key thing for the operators going forward. So that was just an example on what can operators do on the operational side. To wrap up, the kind of recipe for the successful small cell backhaul, I would like to highlight that the small cell backhaul, is just a part of a regular backhaul. It should carry also the functionalities, features, and benefits of the existing backhaul networks. Fastest way of providing coverage small cells is to extend the existing backhaul. One needs to have cool tools for end-to-end visibility and manageability to be able to run the network in an efficient manner. Optimized devices will be needed to be able to offer low total cost of ownership for these deployments, and then good tools for planning, auto-configuration, and mass provisioning will help operators to make the small cell backhaul business case successful. So that's all from my side. I think we would be open for Q&A.
Okay, Tuuli, thank you so much. I'm going to I'm going to show the poll from earlier today. So, John, if you could make me the presenter again. I'm going to share the results from the first poll we had. Tuuli and Stuart, thank you very much for your presentation. We have a lot of questions queued up, and we've got about 10 minutes left in today's call. One of the things I'd like to do is perhaps start with Stuart and Tuuli commenting a bit on the first poll we had, which was what is the most important issue to resolve in order to start widespread small cell deployment. Our audience mentioned that 53% of them said that the financial model and business case for deployment was most important, followed by a deployment model resembling broadband access versus the RAN. Stuart or Tuuli, you care to comment on either one of those two topics?
Yeah, this is Stuart. So thank you, first of all, for everyone who participated in the poll. I don't see those I guess results as very surprising. Starting with the financial model, one of the things that's pretty universally accepted is that the actual endpoints, so the small cells themselves, coupled with the radio technology and whatever aggregation technology and so forth, really needs to be cost effective given how many of these devices would be out there. And so that's obviously probably the most pressing challenge. It's also worth pointing out that where these things are located really counts. So for example, there was a presentation last fall that a guy from BT gave that talked about, one of the things people talk about with small cells is maybe we put them on lamp posts that go down the street. And he pointed out that in the city of London, for example, just the lease fee to lease capacity on a lamppost, to the city was something like £1,000 per lamppost. So it was, it's still something that I think that operators are wrestling with. The other point about the deployment model, this is sometimes an overlooked issue, but it's a pretty important one. In other words, as you have this propagation of small cells that are deployed all over the place in buildings and on streets and so forth, it really does start to look like a consumer broadband model for both turn up as well as maintenance and support and so forth. And so you could run the risk of, if you don't deploy it right with the right network management tools and the right architecture outlays to, run up a lot of operational costs through truck rolls and so forth. So getting that part right is also very, very important.
Okay. Well, I'd like to, Tuuli, do you have any comments?
Well, I'm not surprised about the results. I think the financial model or the business case for the deployment is really the biggest headache for all of the operators just now. And I think, the vendor society must do all we can to make the deployment as easy as possible and the total cost of ownership as low as possible. And then, of course, I think it's going to be a big issue for the operators to think through whether they do their own build-outs for the backhaul for the small cells, or whether they lease it from someone, or whether they will share it with someone. So I think those are also key sort of like decisions that will help the financial business model as well.
Okay, good. Well, I'm going to turn over to the second poll, and which is, what is the estimated small cell backhaul capacity requirement? And I'm going to move in to ask some questions of the speakers while we allow the audience to vote on some of these on this question. But Stuart, one of your slides early in the presentation talked about the exponential growth of small cells, and you mentioned that Asia Pacific looked like one of the higher growth areas. But my question is this: what do you see as the real tipping point where carriers have to address the small cell? What is the key catalyst? I mean, you can business model and plan yourself into a corner, but at some point you're going to be forced to deploy. What are you seeing, and what do you anticipate being as the key driver that's going to really force folks, to carriers specifically, to deploy small cell?
From our perspective, we always have to go back to what's the operator environment look like. And small cells, if you go back to the 3 use cases, which is capacity coverage and hotspots, white space coverage and not spots, and then aesthetics, those are probably roughly in order of priority. But they all come back to providing coverage that would be inadequate just through macro cells. And so that in turn takes it to, okay, it's about user experience at the end of the day, and user experience becomes really, really important the more competitive the environment is. So for operators to, as they get to these competitive environments, and consumers have more choice, and as other ways of differentiation become more universal, then this becomes an important sort of tool in their arsenal. And so it's, I would say the tipping point will be, when operators feel like, number one, back to the poll, that the economics make sense, and it seems that we're starting to get pretty close to that. And then secondly, when do they believe that this is an important step to take to reinforce their consumer experience, and to maintain stickiness of subscribers and so forth, because reacquisition costs always is the most important and expensive proposition for these guys.
Okay. Well, we've got about 3 minutes left. I want to hit on a couple key questions. The first one is, what's the role of aggregation in small cell backhaul?
Tuuli, do you want to take that one, or do you want me to take it?
No, I can take that one. I think the role of aggregation is really sort of, to make sure that, the backhaul links that you have in there are utilized in the best possible way. So to make sure that operators don't overinvest into the last mile, but rather utilize it in the way that, it will be, optimized from utilization point of view. And then I think that stat gain is obviously, one of the key things for operators to consider as well. If most of the data that small cells are generating is going to be browsing best effort data, then I think operators should consider carefully whether they really sort of dimension the network always per peak rate, or whether there would be room for stat gain as well. And then, of course, on top of that, this demarcation point functionality that comes as an add-on if you do aggregation within the small cells chains is a good good benefit for operators as well. It brings manageability, visibility, troubleshooting capabilities within the small cell chains as well. So those are no more like a black hole from management point of view.
Okay. And then final question, in your estimate, how much savings can be gained with optimized installation?
Well, Stu can probably fill in, but I can take that first. I think that there will be significant savings. How much? It's difficult to say, but if we can like eliminate totally human sort of intervention from network operator center point of view from the deployments, I think it's going to be significant. And then especially when we take into account the fact that operators can not only lower the total cost of related to the human hours of work that is related to that deployment work, but also they can make faster rollouts. So small cells would be deployed faster and they would be then generating revenue in the network rather than wait for installation orders or work orders from other parts of the organization. I think that would be the significant enhancement for operators.
Yeah, and I would just reinforce, I think Tuuli made a really important emphasis there, which is that small cells themselves over time are going to start to resemble, again, the consumer broadband model, right? They could, eventually start to look more like DSL modems or PON termination points and so forth, ONTs. So in other words, that in and of itself isn't going to be the defining factor. The real defining factor is minimizing operational cost and administration headaches that the operators will have to face. So you have to look at it very holistically and not just look at the endpoint itself, because that'll become sort of a baseline characteristic and not the true, the centerpiece of the economics. I did want to make one other quick point, because there were a lot of really good questions that came in, and obviously we don't have time to answer them all, but there were a couple of questions that focused on how does Wi-Fi and in sort of traditional broadband access points interplay with this whole small cell dynamic. And that's the subject of a whole other discussion, but it is something that's going to have a strong presence in the HETNet environment. And so I would just round it out with two key points there. Number one is you want to make sure as an operator, as you do these small cell deployments, that you're not just reinventing sort of a glorified Wi-Fi network, because that wouldn't really be a good business model. But having said that, there are a couple of key advantages that if you can implement small cell infrastructure correctly, it'll provide an advantage or a complement to Wi-Fi networks. So you certainly have a mobility characteristic that's better with small cells versus trying to log in from hotspot to hotspot. There's also the security aspect where, particularly for business traffic, enterprise uploads, as things move to the cloud, you can make the small cell connectivity more secure than just traditional web access through a Wi-Fi hotspot. And sure, you can secure the service layer with IPsec or what have you, or SSL, but the increased capabilities and mechanisms for secure transfer of traffic is not to be underestimated. So the net effect is it is going to have a complementary role to Wi-Fi. It has to be cost effective to be implemented, but it also has to show additional value versus just logging into a Wi-Fi hotspot infrastructure.
Okay. Well, we are out of time. Tuuli and Stuart, thank you so much for your time today, and the audience. We had great interaction and participation. There were a lot of questions that were submitted. We have those documented. We'll be handing those off to Tellabs for follow-up. And this presentation will be made available. We'll be sending out an email to all the people who registered and attended today with a link to the presentation. You see the slide up on the screen. If you do have additional questions, please send your questions on small cell backhaul to ask@tellabs.com or visit their website at tellabs.com/mobile. Stuart, any last final comments? Tuuli, on your side, I'll leave the last word to you.
Well, Tuuli usually gets the last word in, so I'll just say thanks again for the participation today, and we're happy. Again, there are a lot of questions that we couldn't get to on the call today, so we're happy to follow up with those if you email us or whatever mechanism works the best, and we'll be happy to answer those.
Great.
Hey, thanks for all of the attendees, and as I get the last word, go to tellabs.com/mobile. You can see lots of additional content on small cells. There were a couple of questions there in the Q&A session asking specific things on our devices. Feel free to come back to us via the asktellabs.com and, find content on our solutions for small cell aggregation from the website. Thanks a lot.
Yeah, we also have a white paper that covers a lot of these issues in more detail that you can find on the website, as Tuuli said.
Great. Well, thank you very much. We'll end the presentation now.
Thank you.
Thank you.